Getting the derivative means that you get the gradient at a specific point. The symbols used for derivatives are the following: d over dx, dy over dx, y prime, and f prime of x. To calculate the derivative of a function, you need to know the power rule. The power rule states that you multiply the coefficient of x by the exponent and then you reduce the exponent by 1. So to get the derivative of 2x to the power of 3, multiply 3 by 2 and reduce the exponent by 1 to give you 6x squared. With negative 3x to the fourth, multiply negative 3 by 4 and reduce the exponent by 1 to give you negative 12x to the power of 3. When you have a variable to the power of 1, the derivative is just the coefficient, because you multiply the coefficient by the exponent, which is 1, and the exponent reduces to 0. And when the exponent is 0, it simplifies to 1. So the derivative of x is 1. And for example, the derivative of 5x will be 5. And lastly, the derivative of a constant, which has no variable, will be 0. Here is the graph y equals 2x. Let's find the derivative with the power rule. 2 times 1 is 2, and 1 minus 1 is 0. So the derivative is just 2. If you look at the graph in red, you can see that the gradient is constant. It doesn't increase or decrease. And that is why your derivative is a flat horizontal line. Y prime is equal to 2 because the gradient stays the same all over the graph. With y equals 2x squared, you can see that the gradient now changes. From left to right, it goes from a negative to a positive gradient. Let's use the power rule to find the derivative. 2 times 2 is 4, and 2 minus 1 is 1. So the derivative of f prime of x will be 4x. Now you can see the gradient goes from negative below the x-axis to positive above the x-axis. And the turning point of the red graph is where the gradient is 0, or where the green line cuts the x-axis, where y is equal to 0. Let's take a look at a cubic graph. To get the derivative, we use the power rule again. Multiply the coefficients with the exponents and reduce the exponents by 1. The derivative of the constant 1 is 0. Simplify the derivative to give you y prime is equal to 9x squared plus 8x. Graphically, it will look like this, a quadratic graph. And remember, the derivative in green is the gradient at a certain point of the red graph. Where the turning points are of the cubic red graph, that's where the green derivative graph is 0, where it cuts the x-axis. Where the gradient of the tangent line is negative, that's where the green graph is below the x-axis, or less than 0. And where the gradient of the tangent line is positive, that's where the green graph is above the x-axis, or more than 0. So when the gradient of the tangent line is positive, the derivative is positive, and when the gradient of the tangent line is negative, then the derivative is negative. Let's take a look at this question. Find the equation of the tangent line to the graph y equals 2x squared plus 3x minus 5 at the point when x is equal to 1. We know that a tangent line is a straight line, so we want our answer to be in the form y equals mx plus c. The equation looks like this in red, and the green line is where x is 1. So to find our coordinate, we need to use the quadratic equation and substitute our x value in to get our y value. 2 times 1 to the power of 2 plus 3 times 1 minus 5 is equal to 0. So our coordinate is x is equal to 1 and y is equal to 0. Now we can use the derivative to calculate our gradient, or m in the straight line formula. So we have to use the power rule on this quadratic equation to get the derivative of the tangent line at the point where x is 1. Multiply the coefficients with the exponents and reduce the exponents by 1. Yet again, the derivative of the constant positive 5 is 0, so we can leave it out. We get our derivative as y prime equals 4x plus 3, and now we can calculate the derivative at any point. When you substitute 1 in the place of x, then you get the gradient of the tangent line, where x is equal to 1. So 4 times 1 plus 3 is 7. So now we know that our m, or gradient, is equal to 7. We have a coordinate and we have the gradient. So now we can work out the y-axis intercept, or c, of our tangent straight line. Substitute your x and y values into the equation and calculate c. Subtract 7 from both sides and then you get c as negative 7. And thus you have the equation of the tangent line where x is 1. The equation is y equals 7x minus 7, and it looks like this in green. Another common question is to calculate the stationary points, also called the turning points. Turning points are where the gradient of the tangent line is equal to 0. So we need to find the derivative of this cubic expression. Rewrite the expression like this to make the power rule easier. X to the power of 3 divided by 3 is the same as saying 1/3 multiplied by x to the power of 3. Now we can use the power rule. Multiply the coefficients by the exponents and reduce the exponents by 1. Yet again, the derivative of a constant, for example plus 2, is 0. When you simplify the derivative, you'll get f prime of x is equal to x squared minus x minus 6. The turning points are where the gradient of the tangent line is 0. So make f prime of x equal to 0 and calculate for the x values. You can factorize this quadratic, so you don't need to use the quadratic formula. 0 multiplied by anything is 0, so make x minus 3 equal to 0 and x plus 2 equal to 0. Then you have your two x values for the turning points, where the gradient of the tangent line is 0. Your first x is 3 and your second x is negative 2. The order doesn't matter. Now you need to find the corresponding y values. Make sure you use the f of x cubic equation and not the f prime of x derivative equation, because you want to find the y values of the cubic graph. Substitute 3 into the f of x equation and you get negative 11.5 for your y value. So your turning point's coordinate is x is 3 and your y is negative 11.5. Substitute negative 2 into your f of x equation and calculate the corresponding y value. When x is negative 2, then your y is 9.33 repeating, and thus your other turning point is x is negative 2 and y is 9.33 repeating. Graphically, it will look like this. Thank you for watching, and I hope you understand derivatives a bit better now. Good luck on your math journey.